All right, well, nice to meet everybody. So I'm Stephen Palubiak, and looking forward to getting to know everybody. Born and raised here in St. Louis. I work for Spectro Cloud. If you're not familiar with us, we've been around for a few years, based out in San Jose, California. And in my responsibility, I'm working with a lot of enterprises on their cloud native journey, specifically around Kubernetes management. And so I'm really excited to be a part of this community and getting to know everybody. Today, as we kick off the CNCF year, as our first meeting, our planning committee said, Stephen, why don't you just give an overview, general, high level? You guys are a lot smarter than I am. So this is going to be basically like for friends and family, like a little bit more of introductory. So I don't know from our audience, maybe it's a little bit too basic. We can dig deeper into different things. But what I wanted to do is take a step back and just look at, okay, where are we with the landscape today? What are some of the core components driving modern applications? What are teams running into, some challenges and things of that nature? So please, collaborative, you guys, if you know these technologies, if you're interacting with it daily, I would love to hear more feedback and how you're using it, good, bad, anything. But before we really get started, I figured the best way to talk about cloud native and all of this development that we're all working on, there's no better place, more logical place to start than a piece of paper. So with a piece of paper, we can write on it, we can write letters, we can use pencil and pen, and we can draw pictures and so forth. And over the years, there's been other developments that you can do with a piece of paper. Now, you can create a paper airplane, but you can also do much, much more than that. And there was this pioneer, Akira Yokosawa, and what he developed was a way to create origami, not just the things like the crane that we've all learned as a kid, or many of us have learned as a kid. And I did bring some stuff, so afterwards, if you guys ever want to try it out, I've got like a little book here. You could do a little carp or anything of that nature. What he realized, though, is beyond just this little basic thing that what you can do, every piece of origami is based on circles and lines. There's different patterns that you can create to develop any design that you can imagine. But it's not just circles and lines. You can't just draw that. There's also some different core elements about this that you have to stick to. So very simple. You have to know things such as the mountain fold, the valley fold, the turnover, the squash fold. These are just some of the very basic types of folds. If you can master those, and then also what he uncovered is that there's 4 core principles. One is that those mountain folds and valley folds is always going to differ by 2. Also, if you look at the inside of this, if you open it up any angle, let's say there's 10 angles. When you look at angle 1, 3, 5, 7, and 9, it'll always equal 180 degrees. You have to keep that in consideration. Also, there's 2 different colors on here. No fold should ever intersect with more than 2 colors. And lastly, this paper is inextensible, which means that in order for me to create this carp, I must always be able to, I must not stretch it or shrink the paper in order to get my object. Now, some of us, we would maybe want to create these types of designs, but we don't really know exactly how do we create this pattern. There's a cool tool out there called TreeMaker. What TreeMaker does is it allows you to put your quote unquote declarative figure, what you want it to look like. I want to create a deer. I have my legs, my tail, my antlers. And it tells you, here's the pattern, here's the circles, here's the lines that you need to incorporate. And it'll provide this to you. As long as you follow these instructions and you stay within these principles and you don't mess it up, you too can have a reindeer. So what does that have to do with cloud native applications? Well, years and years ago, we started out with that white piece of paper, our bare metal servers that were, the infrastructure and applications were hardwired within that data center. We talk about monolithic applications. All that business logic was right in one location. And then came virtualization with things like VMware, and then we could abstract our infrastructure and applications and be more free. And then AWS and Azure and GCP are a paper airplane. And today we're in that world of Kubernetes, cloud native, and into the real paradigm shift of origami and what we can do with it, empowering us to do things like AI, machine learning, edge computing, and a whole host of other things, as long as we can figure out how to put it all together. So we have a lot of different options that we can do, that we can leverage. The CNCF landscape today has over 800 official projects and is growing exponentially every single day. But making sense of this can be incredibly difficult. Where do I even begin? How do I create a carp if I don't know what all those different lines and patterns are? All right. So again, how do you narrow it down of these 800? They're not all going to be super, super applicable. A lot of these, as you develop your applications, you don't necessarily have to pay attention to. Just as with, again, going back to origami with their core principles, as we develop, deploy, as we manage our applications, whether they're monolithic or microservices architecture, we always have to stick to these core principles. Is it scalable? Can we do observability? How resilient is it? In my prior role, I worked at AppDynamics, and we talked about mean time to resolution. And it was not just about uptime, the 5 nines, that's not good enough. It's about any degraded performance whatsoever. As the developers are deploying this, what's that overall experience? How do we automate it? Can we move it around? Is it portable? And then lastly, how secure and compliant is it? Even if we're not in a regulated industry, we always have to keep those things into consideration. And as you can see here, there's a lot of challenges to address all of these different components. And so here's just a few of the examples. We'll touch on some of these, not all of them. And then in follow-on sessions and in future meetings, we can dig deeper into all of these. So again, we'll touch on several of these about what are they, what are some of the things that they solve, what are some example use cases, and some challenges. And in order to help entice some of you to speak up and help add to the conversation, I did come prepared with $5 Starbucks gift cards, so you can get yourself a coffee. So if you have anything else to add, to contribute as far as how you're using these different technologies, good things, good, bad, everything else, please speak up, and you can earn one of these. All right. So as we dive into it, again, we talk about monolithic and microservices. In this audience, when I was preparing this, I wasn't sure, again, who the audience was. Is everybody here technical? Super technical? Is anybody like a little bit more new? Is anybody new or everybody's technical? Okay. Okay. All right. All right. If you guys, so again, I didn't quite know how much depth. So if you guys think this is too high, we can dig deeper. But microservices, it's simply a way to break our application into pieces so that our developers, if they want to improve an e-commerce website, now being able to use, make changes to accounts, inventory, shipping, and so forth without bringing down the whole application. And it's really empowered teams to accelerate, to innovate faster. But it's also exposed a lot more complexity, and it's been a lot harder to debug, to monitor, to really provide more control over those. All right, the next thing is we get more into building our application. So declarative configuration, everybody know what declarative configuration is, and do you utilize it on a regular basis? Anybody not know? Okay, there you go, thank you. So declarative configuration is simply a way to say, again, I want to build this carp. This is the end state that I want. And then now go ahead in Kubernetes and make it happen. That's essentially what we're doing. And so here's what I want now, make it so. We can also think of it kind of like a thermostat where it's 72 degrees. I want to make sure that my room is always at 72 degrees. I don't necessarily care how it gets done. I just want to make sure that it happens. All right. Ian, do you want to earn the first one and add anything else to add about any of this stuff? You don't have to, but okay. All right. Now, how do we go ahead and deploy and write our code? So we have a few different options to actually instrument this. One is YAML. YAML is human readable code, basically saying contact name Steven, organization is CNCF, and so forth. Now, as we do this and we deploy it, it's super simple, very straightforward. It'll be much better for our simple applications, but it's not as repeatable. And so it's going to have a little bit more challenges when we go to scale and work across more complex applications. The next is Helm. Everybody use Helm? Okay. What's the experience with Helm been? Good, bad? Yeah? Okay. Yeah. Okay. So where YAML is basically like a Word document, you can go ahead, you can instrument it within your application, it's going to be one thing for staging, one dev, prod, and so forth, but it has to have a lot of different changes. Helm is essentially a template. It allows us to be able to pull in different key values, so to speak. Now, this is going to be able to help us deploy more consistently across our applications, but again, it introduces more complexity and a steeper learning curve. And then my friend here is Kubernetes. This is what we do. Yeah, go ahead.
Move from YAML, when you're doing the declarative to you made the jump, but what's the
how do I turn YAML declarative?
So what's the connection between you do you show you have a template in YAML and then you use Helm to deploy, right? So I think it may not be very apparent, right?
Can you better answer that? Yeah, for sure.
Yeah. So the way that Helm works is that it consists of when you build a Helm chart, it consists of a collection of YAML files. The YAML files they're basically just flat text, just data. But a Helm chart, you have your flat data, but then you also are injecting variables into the Helm chart. And then you'll have what's called a values.yaml. It's kind of the core part of a Helm chart. And you'll have various values YAMLs for your individual production environment. So you might have one for production, one for dev. You can layer them on top of each other. So we do this at Microsoft where we will have our values YAML that we use for everything, and then we have a values-dev.yaml, and that's what we use for our development environments. So yeah, it's basically just a way of plugging in variables.
What is a Helm chart?
That's a good question. A Helm chart is a collection of YAML files. So Helm is the package manager for Kubernetes. So basically, if you wanted to deploy an application to your Kubernetes cluster, you would want to apply a bunch of YAML to the cluster. And Helm gives you a nice way of just packaging everything together so that it's all in one little nice place. And then you can just, as a user of that package, you can plug in the values that you care about. You don't even worry about creating a big deployment file or a big pod or a big service or whatever other kind of thing that you would need to worry about. You just plug in the things that you care about.
It's more than just YAML templates. More than just YAML more. They're actually templates, right?
Mm-hmm.
So to me, one of the issues here is what I've seen it become is basically JSP for YAML. Because just like JSP was a templating language, I want HTML, but I want to inject a whole slew of logic in there, right? That's what YAML templates have become in Helm. At least I've seen it implemented. In fact, one project that was on a couple hundred microservices had the God template, which was basically one Helm chart to rule them off. And regardless of what service you're deploying, everybody uses the same Helm chart. And so it became this just unholy mess of text plus all the logic that they injected in there to figure out how to generate the YAML that you ultimately wanted to deploy. And they thought that was a good idea. Back to JSP, correct?
What does the template support, like conditionals and loops?
Oh yeah, it does. Yes, like loops.
It's not just like a bash variable substitution.
It definitely has its ups and its downs.
It's basically the Go templating language.
It's like yes.
Yeah.
You can write Go in a Helm chart?
But effectively, yes, it's Go-like. It's very Go-like. The Go has a built-in library which is called the template library, and that's what Helm uses as its templating. So.
Yeah. No, all good. Yeah, appreciate it. Yeah, there's a whole bunch of different components and different elements to it, and then I also didn't touch on customize, which is another. Yeah, there's a whole bunch of different. Yeah, go ahead. Yeah, I have. Yeah, you're right. Later, I have K3s. I did include the S there, but I do. Yes, thank you. Oh, okay. So the reason for that was I had to throw something. Yeah. Anyway, but yeah. There are a few things. Ignore those though. All right. So Kubernetes is really becoming quite the orchestration tool for a lot of cloud native applications. and basically a way for us to not only deploy and scale, but also do more self-healing, auto-discovery of our applications. And there's a variety of different tools out there aside from Kubernetes. It's just kind of one of the de facto options. And what this does is it helps solve for consistency, again, for scaling, and then going back to that declarative state, helping us with some of the self-healing across those different environments. What we run into a lot is a lot of teams are saying, well, we want the benefits of it because it's pretty cool to help us with all this stuff, but also we don't really know how to do it. It's more a steep learning curve. There's a lot more challenges that go into it. So that's kind of in a nutshell, but what it does is, again, it helps us kind of scale these applications, orchestrate all the different components with it. Anything else? Anything? How's the experience been? Are you guys all using Kubernetes or? Yeah, what's that?
Yeah, Kubernetes is great.
Yeah.
Kubernetes is magic.
It is, right?
It's crazy. I tell it to do it, it does it. I tell it what I want, and it does it. I don't tell it how to do it. It's magic.
You were gonna say something?
Yeah, I like the fun wordplay in naming.
Yes.
The wordplay in the naming?
Yeah, like what does Kubernetes mean?
Do you know what Kubernetes means?
Oh no, I don't know what Kubernetes.
It means pilot.
Pilot?
Istio means sail.
Oh, got it. Okay.
Helm is what the pilot uses to control.
Okay.
They're
All right. Awesome. By the way, you did earn this already, so this is yours. All right. I'll set that one to the side. All right. Then also now, how do we interact with it? And probably the core thing is something called kubectl. That's our command line interface. And that's the way that we go ahead and we really can manage these clusters, all the different resources. That's how we can create pods, scale everything, and really just interact with it.
What's a pod?
Yeah, what's a pod? I'll let you elaborate on that one.
So a pod is just an abstraction around a container, like a Dapr container, for example. And a container is an abstraction around a binary. So it's a way of isolating your resources into one little package and then effectively being able to use it as a binary without having it mess with other systems. That's kind of what the magic of Kubernetes is, that it allows you to orchestrate all of these containers. So they all work together. You got one container for your database, you got one container for your front end, you got one container for your back end, and all this kind of stuff, and it just all talks together. Yeah.
So in your application, you just have one pod that contains all of the containers?
Not usually. The most basic services might have one pod, but larger, well, kind of like I was just saying, you might have a pod for your database, a pod for your backend, a pod for your front end. There might be, you can have tons of pods that are all working together to form a service.
My understanding was the pod was kind of like a server. You have a bare metal server. You can put many containers on it, but it kind of operates on one operating system.
Yes, more or less. It's like a, again, isolation is the important thing. It's that, if I make a pod, I can communicate to it, but I can't necessarily see the file system, and it can't see my file system. So,
does the pod enforce the constraint that all the containers in the pod run on the same machine, or is that different?
pods, yes, pods all run on the same machine, but pods don't necessarily, containers within a pod run on the same machine. Pods within a cluster do not necessarily run on the same machine. You can have multiple nodes running on, a node is an abstraction, but a node would be like your servers. You got a bunch of servers and you're running pods on top of those. The pods are going to be placed on servers as needed. That's another really important point.
It's super simple.
Yes, same.
Yeah.
I demand 3 active pods.
Or reconciliation paths. So you describe your target environment and what you want to look like. You want so many of these things running these containers with these memory CPU constraints. Go do it. And it figures out based on its knowledge of existing resources where to run those things to satisfy those constraints.
Yep.
Mm-hmm.
Yeah, exactly. It makes things like scaling very easy. Very easy. You just say, I've got three instances of my server running, and I'm seeing a lot of load, so things are slowing down. I want to get more servers out there. I just scale up. I say, okay, now instead of having 3 pods, I want to have 7 pods. And Kubernetes just figures it out. So, okay, well, let's go create new nodes or find new nodes wherever they're going to be, however that system works. And it scales it up, and it's magic.
Awesome.
You can also be potentially using that for like if you have requirements around like not just how many or how much power, but then where. So like if you want to be trying to distribute your resources, say you want to have a pod that's in central, and then you can have pods in other regions to try and keep availability high and keep a quick path for your different users. That's another thing that it automatically does for you if you specify.
Or if nodes have specific hardware
Yes.
constraints like GPUs.
If you want to run AI on something, some AI application, then it's going to need to be on a GPU. So yeah, you tell it this needs to find a node that has this specific set of resources.
But this is based on the assumption that you already have these nodes pre-provisioned and have Kubernetes installed on them. It's not doing like a Terraform thing and going out and buying the nodes with your credit card.
Which vanilla Kubernetes, if you're doing it on bare metal, they have to provision. But that's a tricky question because there's lots of ways that you can spin up nodes.
This is a rabbit hole.
Yeah, there's a lot of rabbit holes, so there's probably a rabbit hole on each slide here. All right. So then, okay, so we kind of figured out YAML, kubectl, and we want to start applying even more custom things and different kind of create a custom menu because what's on there is not quite good enough for our particular application. So now using custom resource definition or a CRD, that allows us to go in and now add other variables. Typically, this would be things like your infrastructure, it'd be like a MySQL cluster. Not sure if you have any other examples, but there's just a couple of things that kind of came to mind. But again, with just like the other ones, challenges, again, kind of debugging typically comes up with trying to figure out, okay, why is this causing an issue? Also, it's going to be more specific to the application as well. Okay. If you guys have anything else to add, feel free. But
Okay. Any question on CRDs, custom resources?
Do you know if there are any good references for designing and writing
Your own controller? Your own
Yeah, that is
CRDs?
control obviously, right, but also defining the CRD. Design, I don't think it was a pattern to really even around that.
Right. The only experience that I personally have is with KubeVirt controller runtime. There's a KubeVirt book out there. It walks through all that kind of stuff. Design. There's also a tool called, I'm blanking on it. Ask me after the talk, I'll remember it. There's another really big one that I'm just forgetting right now. KubeVirt is one I have.
I don't have a need, I'm just interested.
Yeah, there are resources.
Okay. All right, and then kind of building off of this is now how do we really teach our system, leveraging our CRDs to continuously, automatically manage these complex applications. So the next thing now that we start kind of building a little bit more structure around it, these operators, and here in a moment I'll talk a little bit more about some different flavors and different options here to help you achieve this. But again, basically you have your CRD that says, here's my custom menu. Your operator is helping watch and change any events to apply those to your clusters, leveraging Kubernetes.
Operator SDK, that's the other one.
Boom, there you go.
Can I actually loop that last slide back into your commentary about declarative versus imperative?
Yeah.
Because like the big goal of this whole operator paradigm is now you want to be declarative, not just for like the Kubernetes native resources or specs, but it's like now that you understand your business or like what your application's needs are, now you can be declarative with your whole system. So like this is a pattern that in my understanding gets used a lot in like a lot of this space here for the Cloud Native Foundation. So like I've worked a lot with like Strimzy is like another one, which is Kafka. So that's like, I want to run my Kafka cluster in Kubernetes. I don't want to have to figure out how I scale my Kafka brokers and then translate that into a declarative language. I want a declarative way to run this myself. And that's kind of this pattern. So it's like, it's taking that layer of like, say what your ideal world looks like, and then make it work for what you need. That's where this gets really powerful and really special in a lot of ways, is when you can use it for being declarative for the things that matter to you.
Is the operator where does it fall on the spectrum of like some kind of Ansible Black Bash playbook or its own kind of microservice that's making HTTP REST calls?
It's a little closer to the microservice mindset because typically an operator runs in Kubernetes. It's not like HTTP REST. Usually, it's more native to the Kubernetes.
You can almost think of kind of like a plugin.
Yeah.
To the API section.
Yeah, precisely.
Cool. And then, yeah, as mentioned, operator SDK. So a few different options. You also talked about KubeBuilder a moment ago. So it just depends on how much control and flexibility that you really desire. So the operator SDK, a little bit more simple. It's more kind of that kit, that pre-made kit, and you plug and play. It's a lot more simple to get it up and running. I think you were just talking a second about Ansible is one of those that can work well with. If you want to go to the next level up, KubeBuilder kind of gives you that framework. Now you can start building your own kit, and it says, okay, here's a little more custom logic. You can add more structure. It's, again, kind of getting a little bit more custom. And then controller runtime, that's really where it's high control and high flexibility. This is essentially, here's all the raw materials. Here's everything that you guys need, that you need. Now you go out and you build it. Have you found more success with, you were talking about KubeBuilder earlier, but how are you, if anybody, leveraging controller runtime? Or how do you choose between one or the
So KubeBuilder is like you got it here, it's a framework. It's more like a scaffolding tool. You kind of describe what you want your operator to look like, what your CRDs look like, and it will generate that stuff for you. By default, I don't know if this is even customizable, but by default, it actually does use controller runtime. So once you actually start writing your code, you will be using controller runtime. You don't have to use KubeBuilder to use controller runtime. You could write everything custom and just do it from scratch. And for that matter, you actually don't even need to necessarily use controller runtime. You can use the Kubernetes libraries directly, although you would be a little bit hardcore if you were doing that. But yeah, that's KubeBuilder and controller runtime.
Okay, cool.
So you said KubeBuilder, in addition to implementing some kind of operator, it also generates a custom resource definition, maybe for some kind of service or recipe that the operator is then adding functionality for managing the lifetime of?
Yeah, so basically a CRD, custom resource definition, is it's kind of your API. You kind of describe the things that you want to make customizable, that you want your users to be able to interact with. And then they provide you with concrete instances of that CRD. We call them a CR, custom resource. And then the operator will be watching for those custom resources, and when it sees them come in, it reconciles them. It says, this is the spec that you want, the specification. We're going to do a bunch of work in the background that is imperative work that you don't have to worry about, and it's going to make it so. It's going to make it a satisfaction you want to do.
Awesome. All right. Kind of circling a little bit back more to the YAML stuff in our code and what we're writing and like where do we put it? Where does our declarative state go? And that's so we talk about Git, GitHub, GitOps. And there's also different flavors of GitHub and so forth. So Git is basically, this is our single source of truth. This is where we throw everything. GitHub, you can kind of, I kind of think of it more of as a Google Drive. This is where I can access it. This is where my essentially kind of like my portal to get into it and to access that code. And then GitOps, it's not necessarily a tool itself. It's more of a methodology. And then the tools within that would be things like ArgoCD. And ArgoCD, that's your continuous delivery tool. So I got infrastructure as code, config management, all that code there, again, gets put in Git, and then we use GitHub and so forth to pull it out. And then it continuously runs and watches for all of that. Our operators and so forth keep an eye on all of this information. Yeah, again, if anybody has any questions or anything.
What about, I guess, secret management? You don't want to necessarily put all your secrets into the Git repository. Is there a system you'd like to do for managing that works well with your CI/CD deployments and Kubernetes?
There's a, well,
Yeah,
yeah.
I don't have anything for that. I mean, you're right. You don't typically want to store it in the same repository. You want to store it somewhere else in some storage that is really full. But I will, I don't have a lot.
You got to configure maps and secrets as resource.
Yes.
I was gonna say, I might build
It's false. I don't know when
You have an idea?
there's a whole bunch of answers, because you can use an external secrets manager. You can the Kubernetes has its own built-in secrets manager. If you want to be able to put something in your Git repository, you can use SOPs, which is a thing that uses basically GPG encrypted. You still have to get you basically have to get that GPG private key into the secret storage of the cluster for it to be able to decrypt things. And there's sealed secrets is another one. I use that one personally for no particular reason. So that one uses certificates that are basically generated inside the cluster, and you just pull down the cert in order to encrypt your secrets.
I've seen a lot of things like databases and stuff go into cert-based authentication and stuff passwords. So then you just have to figure out your cert delivery, which maybe service mesh or something like that can do.
Mm-hmm.
Yeah, that's another big popular operator is the cert manager operator. It's another CNCF project that does exactly that. Manage your certs.
Mm-hmm. Awesome. All right. So then, and now you're starting to deploy your application, but you realize that you also want additional capabilities. Maybe you don't want to write more code. You want to use something like a sidecar. So Dapr is one of the cool CNCF tools out there. You like it, or?
I don't know much about Dapr.
Oh, you don't? Oh, okay. I figured you know everything about all these. So, well, I'll have you speak on it no matter what. You can just make things up. So basically, does anybody interact with Dapr at all? No? Okay.
Is Dapr just a type of sidecar, or is it a service within Kubernetes? I know sidecar, but I don't know.
Sorry, what was the question? Is it a sidecar?
Is Dapr just a type of sidecar, or is it like a service within Kubernetes that does sidecar?
I don't know if I can articulate that answer well enough. I don't know. All right. Well, this is going to be a really good session for us as a group. I actually hope that somebody in this room would know like a lot more about Dapr. But basically, as far as I know, gives your application all these different powers without having to be able to have it instrumented within the application itself. So now you can access all these different things. These are some examples, like secret stores, for example. So if you wanted secret, you could leverage it through Dapr and access it through that way. So the use case that I have here is a retail application needs to access the store shopping cart data and talk to a payment inventory systems, but maybe they don't necessarily want to have all that information on the application itself. All right, we'll come back to this in a future session. Okay, so this is one that we at Spectro we use with core to our platform, but it's Cluster API. This is, I want to deploy, I kind of figured out my application. I'm able to deploy it within my core environment. Now I want to really deploy it more fleet management, do this across all these different environments. So I've got multiple cloud providers. I want to do it on-prem, at the edge. So Cluster API empowers you to be able to do that in a really seamless way and have consistency, again, repeatability. Like some of the other things, it's complex to set it up. And also, even though it is the whole goal here is to have that fleet management deploy it, there are obviously going to be some nuances within the different environments. So this is really cool for companies that are looking to deploy across different locations. Is this something that you guys have all? You guys, yeah.
We use it like crazy.
Uh-huh.
Yeah, that's all I do is Cluster API.
I think everybody says they want to, but they hardly ever do.
Uh-huh. You gonna say something?
I was going to ask, how does this differ from the standard set of Kubernetes resources with Cloud Controller?
I'm not familiar with Cloud Controller.
Cloud Controller, isn't that like the Kubernetes plugin that lets you provision in the cloud as opposed to locally? Maybe I'm using the wrong term.
No. I'm not sure exactly. Cluster API is a way to describe your backends, what kind of nodes you want to use. So, for example, you might have your nodes constructed on top of Docker containers, and you'll use
Okay, so
cluster
it's a
API.
lower level of description.
Yes.
Okay.
Yep.
That's what that answers the question.
And then like trying to keep that synced across like the different nomenclature for these different cloud providers, because running Kubernetes on my own hardware is very different than running GKS.
Yes,
So
exactly. Yes.
okay.
Yeah, it's effectively an API. You say I want a cluster, it knows how to construct a cluster using the resources that are available. So in this case, we're not talking about things like your hardware. We're talking about things like, do you have Azure VMs? Do you have AWS VMs? Do you have whatever. It's figuring out how to do that kind of stuff.
So not wanting to necessarily plumb the details of this right now,
Yeah.
but would that basically require having a controller for each of those target environments that interprets the resource kinds that it cares about in a way that's specific to those environments? But otherwise, it seems like you're in it with a least common denominator sort of solution.
Right. Yes, you do typically need to have an operator that manages that. So the one that I'm really familiar with right now is a cluster API provider, KubeVirt. KubeVirt is it's a virtual machine provider for Linux. Effectively, it's the front door to libvirt. And if I wanted to create a cluster on top of KubeVirt virtual machines, then I would have to count KV, KubeVirt, cluster API provider, KubeVirt, letting it's on a cluster API.
Mm-hmm. Cool.
So
All right.
the nice thing is that the providers create those. I don't have to worry about how CapKV works. Someone else makes it and then I use it.
Awesome. All right. I just have a few more, and I know I want to be kind of cautious of the timing here. All right, going back to kind of the microservices, that earlier slide, and how all those different services are going to have inventory, store, whatever it may be. So the other question is, well, how do I communicate and send traffic back and forth between those different services? And so Istio allows us to basically have that communication between those services. Trying to think what else to share on this particular topic, but that's essentially the gist of it, is making sure that we can communicate between that and that they can all know what the other one is doing.
Is Istio the only, just an example?
Just an example, yeah. Yeah, there are other options, and I'm not sure if anybody else is, you're familiar with. Okay, but it's one of the core ones that is being utilized nowadays. Yes, yep, exactly.
Table of 20 to 25 different service mesh implementations that all would need criteria.
Okay, awesome. All right. Okay, so now you have the communications, and that's just one element. There's a lot more than just Istio for our communications. And OpenTelemetry, that's what is basically able to help standardize and capture, really to make sense of some of this data. We send it all our metrics, our logs, our traces. That data then can get sent to platforms like a Splunk or a Dynatrace or you name it, to be able to help you with your root cause analysis. The cool thing about OpenTelemetry, it's a little bit more cloud or vendor agnostic. So a lot of companies will like to leverage that way. If they want to go from one company to the next, they don't have to be tied to that particular company's data or that their collector. Okay. All right, the last couple things I just want to touch on. See, I did have the S. All right, so now you've developed your application, you figure out how to do it, you started deploying it, and then now you want to go back and you want to figure out, okay, now how do I deploy different use cases, go to the edge. So we call it K3s, not K8s, basically because that's smaller, it's easier, it's lighter weight, and you essentially get the core benefits of Kubernetes without some of the heavy complexities and so forth. So it may be for a drone or for anything in your warehouse, things of that nature. So, but again, the complexities, there's going to be different challenges, different nuances deploying it here versus in Kubernetes and so forth, because it's a totally different environment and different requirements and so forth.
So we're running the container in a smaller computing device?
Yeah, yep. Like a Raspberry Pi, it could be. I mean, I guess it could be really pretty small, different devices. I'm working with a manufacturing company right now, and yeah, they're trying to do it in their manufacturing facilities. And I mean, yeah, it could be anything. It could be drones It could be sensors within, again, for inventory analysis, anything.
I think one example of this, maybe not specifically running KVS, but Chick-fil-A runs a Kubernetes cluster in every single one of their stores.
Yep.
And those are all going to be typically low power. They don't need a lot of computing resources.
Mm-hmm.
They want something that's going to be K3S, K0S, micro Kubernetes. They all are ways of scaling down Kubernetes implementation to just the bare what's needed, and you can add other things into it then as you want. But you don't get full KAS out of the box. You only get the things you really need.
Mm-hmm.
And many times they also scale down requirements like, what do I need for my resource database? Instead of having high availability at CD on multiple nodes, I might do something like, what's it, MicroSQL, there's some SQL-based implementation.
SQLite?
Not, I think it's SQLite, yeah. It's like an embedded version of a SQL implementation. So again, the whole idea is scale requirements down, single binary typically for all of Kubernetes, it does everything.
Mm-hmm.
As opposed to multiple binaries running on multiple nodes, which you want for high availability. But edge environments don't necessarily need high availability, they have more concern with resource constraints.
Yep.
You said single binary. I mean, there isn't two different binaries for like an agent process and a supervisor process.
That's a good question. Do you have something for that?
I know from a single binary perspective, you're more talking about the queue controller itself.
The controller.
That controller plus NTD, which is all
Mhm.
or the database, which is usually different binary.
Well, you could put this on a server and it would use less resources too, right?
That'd be the whole point.
Yeah.
There's nothing stopping you from putting Kubernetes on a bunch of Raspberry Pis, but if you want to make the best use of your hardware, KVS is a good choice.
Or K0S or MicroKD.
Right.
Mm-hmm. Yeah.
Or if your kind of question was more about like, why don't I just run my microservices as processes on my like bare bones hardware? At least with this K3S route, you still have better native support for containerization and trying to run things as isolated processes, and you get some amount of that declarative model we talked about earlier for like, this is what I expect the system to be running like, and then having that some of that self-healing and observability built in, rather than if you just like initiate 15 threads or whatever on top of this hardware, then like you do have to have somebody usually more observant for what's going on.
But to your point, David, definitely a multi-node Kubernetes configuration, you would have to run something on each node, whether it's the kubelet or the node agent. But there are some minimal things that you have to run on each node in order for them to tie into the Kubernetes control plane.
Yeah. Well, for it to spawn the containers and see the containers.
Awesome. All right. I think this is maybe the last one I had. So you also kind of referenced this one earlier a second ago. So again, now we've got those cloud applications. We got it at the edge. Now we want to go back to our data center. We want to figure out our bare metals, our virtual machines. We're dealing with things like VMware and Broadcom situations. And we're like, okay, what do we do? How do we modernize? So this is a conversation a lot of organizations are trying to figure out. So what you can use KubeVirt to basically essentially containerize your applications, those VMs, run them as Kubernetes, and then you can have your workloads operating in parallel with your Kubernetes workloads, giving you basically an off-ramp from that hypervisor.
Yeah, KubeVirt's a really attractive option right now because a lot of people have gotten used to virtualization. All of their hardware, all of their services run on top of virtual machines. That's kind of what we moved to after some of the big frameworks. KubeVirt just gives you a way to create your services inside of virtual machines, even though they're kind of inside of a container. It's a little bit of a tricky thing to describe there, but yeah, it's just a way to have a virtual machine inside a container. It's really cool.
There may be some other challenges that you may run into, like storage and networking. So that's one thing that they're trying to figure out. If I'm on this older storage, how do I apply? How do I fix that? So things like Portworx, and there's other options out there too, but that's just one example to help better facilitate all of that. So just one of the things you got to think through. Okay, and then here actually, the other one's Backstage. So Spotify created this. This is essentially a portal for your team. Again, you did all this great work. Now, where do you? We talked about Git. That's kind of your source of code and everything. But above and beyond that, where do you put all your documentation? All these other things that need to be included in their service catalogs and so forth. So we've seen this is something that just a lot of teams are starting to pick up, and really, really cool. Are you guys using this yet?
I'm not using it, but it's really cool.
Okay.
I think this is a really cool project.
Yeah. It seems to be coming up in a lot of conversations. All right. We're over by a few minutes, so I'll wrap up here. I'm going to end on just the last little thing. Like here's my little spiel on us. So who is Spectro Cloud? If all that stuff that we talked about, our platform helps manage it. So if you can do all that stuff, it's great. But if a team needs help with managing it, deploying it, and everything else, we do full stack declarative management. We do this across any environment. So we use Cluster API, deploy all these things. We integrate with your whole CNCF landscape. Also enterprise tools, Kong, you name it, Splunk as another example. And then we help put the guardrails around it, kind of give you that glue and allow you to enable to deploy. And we essentially take care of your day 2 operations and everything else. So anyway, if you guys are ever interested, just poke around on our website, check it out. Pretty cool tool, really applicable to teams that are dealing with things at scale and across multiple different environments. So that's all I had. Also check out this Tree Maker. It's kind of cool.
Hey, our apologies for all the technical hiccups we were having. Yeah, the video is not usually like that, but wasn't helping us out today. So anyway, thank you for sticking around, and we'll see you on the next one. Thanks. Bye-bye.